All right, hello lovely humans. Today we are going to do, so for your first e-learning activity, you are responsible for watching this video, okay? And then you are responsible for completing the practice problem in Module 1. So in Module 1 for this assignment, you'll see the video and then below it is a practice problem, very similar to what's on the formative. So your assignment for today is to watch this video and to complete the practice problem on the module. All right, so what's happening for today's video is that we are looking at the given formative equation that we took on Friday. So it says the following reactions occurs at 376 degrees Celsius. Determine the Gibbs free energy of ammonium as it decomposes into nitrogen and hydrogen gas. All right, then it gives you a breakdown of the grading criteria. All right, so the first thing that I would write down on my paper to make sure I didn't forget would be my Gibbs free energy equation. So delta G is equal to delta H minus the temperature and then delta S. So enthalpy minus temperature and entropy. Okay, so the first thing that I have to do before I can do anything else, I have to figure out what in the world this equation looks like. So we give you ammonia as NH3. All right, and then it's going to break down into nitrogen, which is diatomic, and hydrogen, which is diatomic. We're not able to find our delta H or our delta S or our delta G if we don't know what the equation originally looks like. All right, so with this equation, the first thing that I notice is it's not balanced. So my first step has to be to balance it. It's real simple to balance there, nice and easy, okay? Okay, so now step one is complete of balancing the equation. All right, so I have a balanced equation and now I can start the rest of the process. So again, I cannot start till I have a nice balanced equation. A lot of you miss this step. All right, so next thing that I do, all right, I have my balanced equation. I've decided that the first thing I'm going to solve for in my given Gibbs free energy equation, all right, is my delta H. So for enthalpy, we can either use MCAP or bonds breaking minus bonds forming. So I gave you enthalpy values for bonds, which means I have to use this one because that's what's given. I do not have a specific heat, I don't have a mass, I don't have a change in temperature, so there is no way that you're going to be able to use MCAP. All right, so looking at this, most of the time when you're doing a Gibbs free energy equation or entropy is involved, your delta H is going to be found through the breaking and the forming of bonds. All right, so let's go look at what that's going to look like. So given my value, all right, I then wrote out what my bonds are going to appear as. So we've done ammonia a bunch. We should all be able to make this. Technically, there are 2 electrons at the top there, all right, and I have 2 of those. And that's important to remember that I have 2 bonds that appear, I have 2 molecules that look like that, all right? Then on the other side, nitrogen has a triple bond and hydrogen has a single bond. Ooh, too far, sorry guys. Has a single bond, and I'm gonna go ahead and have 3 of those nitrogens like that, okay? So then I'm going to figure out what bonds I have and how many I have of each bond. So I have 6 total NH bonds because I have 3 in the ammonia molecule, and then I have to multiply that by 2. So I have 6 total NH bonds. All right, I only have 1 N triple bond, and I have 3, ooh, too far. I have 3 NH bonds. Okay, and I know that for delta H, it is the breaking of the bonds minus the forming of the bonds or reactants minus products, which is how I know that I should have a minus sign right here and that my ammonia is on the left and that my nitrogen and my hydrogen's on the right. So if I go ahead and then I plug in my values that I have on my given chart, so the enthalpy for NH bonds is 391 minus 941 for my N triple bond, and then my plus 3 times 436. When I add that all together, I get 97 kilojoules per mole, all right? And I know my units based off the values on the given chart. So for the summative, I will give you your values because you obviously can't look them up. It's a summative. So I know that for this delta H equation, I am in kilojoules per mole, which means it's the molar enthalpy. All right. So step 2 technically is now complete. All right. So then I go back and I plug in that I know my delta H. All right. Then I can move on in my Gibbs free energy equation and I can look at my T. I am given T temperature in Celsius. That doesn't work. We need it in Kelvin. So I'm going to have to add 237 and I get 649 kelvins. Okay. Now the last step before I can solve is to find my delta S. All right. And delta S equals the delta S of your products minus the delta S of your reactants. All right. So for this one here, all right, I then go ahead and I figure out how many I have of each. So to calculate my delta S, I have 2 times 192.8, which is the delta S of my ammonia. And then I have my delta S of my nitrogen, plus 3 times the delta S of my hydrogen. Okay, I would go ahead and solve for those. On my product side, I get 583.7. On my reactant side, I get 385.6. When we add that together, I get a delta S of, when we subtract those, I get a delta S of 198.1. Okay, so again, let's break this down. Our delta S's are not based off bonds, they're based off molecules. So the reason that this one's times 2 is because I have 2 of my ammonia molecules. My nitrogen, I only have 1 nitrogen molecule, and my hydrogen, I have 3 hydrogen molecules, okay? Delta S is the delta S for the overall molecule, not for the individual bond, all right? And again, it is products minus reactants, all right? So then my final thing that I'm going to do is I'm going to set up all of my given found values, all right? And I need to make sure that we all have units that work. Okay, and if we look at here, I have kilojoules for my enthalpy and joules for my entropy. So again, it is personal choice whether you want to go kilojoules to joules or joules to kilojoules. For this reaction, I decided that I was going to do kilojoules to joules so that my delta H is actually 97,000 joules per mole. Okay, then knowing that, I now finally can plug in and solve for my delta G. So our units agree, we're in joules and in joules. Okay, I do my delta H minus my delta S times my T. All right, when I go ahead and solve, the original value I get is 31,597 joules per mole, negative. But I'm only technically have 2 sig figs because of my delta H right there. So that means it's negative 32,000 joules per mole. Okay, so if you have any questions, I'm available. Please email me, but you are responsible for your first e-learning assignment is to do a problem similar to this caliber. All right, so I did post the formative grades. And with that being said, when I was looking at them, I feel like we need more practice. And it's not that you guys don't understand the individual parts, but we are struggling to put all the individual parts together as a whole. So what I've decided is I'm going to move our summative back. You'll be taking your summative on Thursday, and then I'll be sharing out the reteach opportunities over break so that when we come back, you'll be able to take the retest, all right? I did not feel comfortable still having your summative on Tuesday when we were not averaging a formative score that was reflective of your learning. We just need more practice. So because of that, your summative will be on Thursday. A reminder, this is an honors code and there are multiple versions of the summative out there. So please make sure that you are not making me regret my decision to push your summative back.